Welcome to day 5 of 12. We have a bit to talk about today, rather focused as opposed to what we usually do. We will have some synth topics to speak about throughout this video, but next week is going to be the big week for that. We'll be in the studio and I'll be demonstrating a number of things. I'll talk about that in just a moment. Today's all about graphics. So I'll be talking about the Christmas album graphics on the Commodore 64 via the Vice X64 emulator. And we'll talk just a little bit about the F256 graphics that were included in the Phoenix Christmas Demo 23 that I distributed on December 24th, which is a bitmap screen. I won't get too much into the depths of or differences between the two machines, but I'll talk about probably 3/4 of this will be about the Commodore Christmas album, which was rather unique, interesting, admired, all the rest of that when it first came out. Next episode 6, will be all about oscillator sync, and we'll use 4 platforms to do that. We'll use a Moog modular Model 15, which is kind of the first portable modular that Moog made. Well, actually, it was the second, but it's the same form factor. The Moog Matriarch, which is a rather modern Moog, probably been out around 2 or 3 years only. It's got some really impressive modulation and patching capabilities, and it has a pretty good sync implementation, as you'll see. We'll also be looking at the Oberheim OB-X8. The Oberheim line, Tom Oberheim, has a storied past going way back to the 70s. And this machine's an absolute monster. Has a kind of a cross-sync capability that is pretty amazing. And then we'll move over to the Commodore SID and talk about sync there via the SID Lab program that I've been working on. So let's move along and we'll jump right into, well, before I jump into the emulator, I want to at least walk you through this article just to talk about what we'll be looking at in a second. Forgetting about the different scenes, I want to mention that the Commodore disk that included the demo had four files on it. We're looking at an article that I published December 24th, and the last page of the newsletter, which is page 25, is a one-pager about the demo. You can download that. I'll put a link below. But you can see that there are 4 files here. I've gone ahead and loaded the 3 of the 4 files already into the emulator, so we should be all set to go there. But I want to point out that this largest of the 4 files, Christmas Music, 149 blocks, is absolutely massive. It's 36K. It loads from 0D100 to 9FFF, which is essentially all of memory, right? The Commodore 64 started its basic space at 0800, so it only has 0800 to 0C FF available for basic, which is interesting. And this file contains not only music but code, a lot of graphics data, all this data over here, all of the character graphics, the colors, sprite data, etc. Christmas code contains code also, and I believe there's some data up there as well. I've gotten through a fair amount of it, but not all of it. So I just wanted to talk about that. I think in total it's something like 56K, this demo. So it's absolutely tremendous. Let's go over now to the emulator, and I'll walk you through a couple of things that pertain to Commodore's graphics and the way this emulator renders the demo, which is more or less accurate. You could argue about the sound, but we're not really here to talk about sound just yet. So I have loaded the Christmas music file, that's the large one, Christmas code, C1000 to CFFF, and Christmas root, which is the basic program. I'm going to list for you, let me change the screen color black real quick, 80,0, just so it's more, shows up better on YouTube. I'm going to change my cursor to white. Okay, good. I'm going to list for you 3 segments of code, all basic code with a lot of machine language calls within, just to talk about structure of this program, and then we'll get into the graphics. So the first section will be everything up to 400. Okay, so you see here some comments, the credits, music credit, Wayne Eastwood, sprites and screens, H-Rex Boucher, I guess, design and programming, Stephen Murray. You can see it does what I just did, turn the screen black, prints a hello message, and then it starts to set up some variables. Then it calls some machine language. So this machine language right here, this 50784, is the opening scene to the Commodore Christmas album intro or demo, and it's the intro. It's the part with the falling snow, and I'm gonna run it just so you can see. But it's pretty good. It's unique before I press enter. It's unique because it's all encompassing in machine. It's a full machine language, piece of code that stays there until the screen changes to the first kind of musical number. So I'll start this. Here it comes. Turn the volume up a little bit. You can see the falling snow. Those are all periods, right? It's just text. And then at the bottom you've got more text and more text and more text. At least it seems that way. Now you'll see the Commodore logo show up. One thing that's interesting, and I didn't know this until I started messing around with it, this is actually meant to be scrolling left and right smoothly, but they never quite got it working. I'll have to look at the code and see why. But now I'll move to the next scene. And now I stop it. Isn't that a long release? Okay, break in 860. So I'm going to move down here. In a moment, we'll have a look at the program and find out why I was able to break a basic program. But I'm going to move down here, and I'm going to do this. I'm going to type continue. And it happily continues. Break it again. Now what I'm going to do is, you're not going to believe this, I'm going to erase a couple lines of text here. I'm even going to come down here and just bear with me. Okay, you might be know where I'm going with this. Okay, and I'm going to type continue and watch what happens. The snow goes all the way down to the ground. So interestingly, this routine kind of seeks its own level, the snow, and will stop wherever it needs to stop. Now the funny thing is, this is look, notice there's no snow here, right? The overhang is protected by this overhang. An interesting thing is that the snow routine is used in I think 3 of the scenes, and it's actually quite expensive, computationally expensive. And I'll tell you how I figured that out. I mean, you could guess that it would be on a 1 megahertz processor, but it's something else. I'm going to stop this one. Okay. Now, if I quizzed you, what would you say you saw on the screen? The answer is sprites and character graphics, and you'd be correct. I'm going to press enter here. You could scroll the text off the screen. You could see the sprites that are there. Okay. Now I'm going to do is I'm going to turn off the sprites. Let's see, poke. There's a 5, 3, 2. I have notes here somewhere. There they are. 6, 9, comma, 0. Turn them all off. Now I'm going to have a quick look to see what sprites are here. Well, there's 8 sprites, sorry, on the Commodore. The first one's the star, such that it is. Second one is the top part of the tree. Third part is the lower part of the tree. Now, a bit like many of the other computers out there, including the Phoenix, they do animation, not just that it's a particular sprite in a particular place. They change the table such that as the music continues, the sprite animates. Now I'm going to turn them all on. I don't know how many there are, but I'll turn them all on. Okay, there they are. Now I'm going to list the second part of the program for you, which is because I can see through that well enough. I'm going to list 510 to 590. Remember the first part? Merely set up some variables and then call the intro scene. The second part, which we're already kind of well into, is the definitions and the main code for each of the scenes themselves. So you've got here Good Christian is the first song. We were just listening to Jingle Bells with the tree scene, and Silent Night Roof, etc. yet to come. There are about 4 different, I guess, components of each line or each song. There's the setup piece, which is this first sis. I'll talk about that in a second. There are 2 sound variables, J and K. Then there's the address, which is written out in absolutely, kind of ludicrous notation, including, powers of 3 to the third power, to the second power, to the first power, etc. And then you go up to 800, which they'll have in common, and that's the end of the line. Okay, now what I'm going to do is I'm going to do 2 things. The first one is I'm going to point out to you something I learned in reading about this Christmas demo, and that's that there were originally 9 scenes. In this demo there are 7 scenes. There's 6 music scenes plus the intro, And then there's 1, which is the sales pitch at the end. So that's the 7th music scene. There's actually 9. Originally there's 9. Where are the other 2? And I don't know the answer, but look at the line numbers here. 5, 10, 5, 20, 30, 40, 50, 60, and then it goes to 90. So clearly 70 and 80 are missing, and I wonder why. And you know what? I'm going to find out. By next Christmas, it'll be my honor to find out if those 2 scenes are buried somewhere inside the code. See if I can harvest any of them and get them running, or maybe find out why it didn't quite work out for them. It's possible it's still in there, but perhaps not. So this is the middle part of the program, 510 to 590. It just sets up each of the scenes. I have to do a quick sys here to show you one quick thing, which is interesting. And if I say sys, let's see, 51976. No, I'll do this one. I'll do 52288. Watch what happens. There's the Silent Night scene. Now that sys call, that single call, renders the scene in machine language, paints the screen with whatever characters it needs, including a transitional scene, sets the screen color background as it needs to for each character, and then turns on the sprites and establishes their placement. Get this off the screen. You can see the sprite there, and you can mess around with that. But anyway, let me get back to the code real quick. I'm going to list 510 to 590 again. To 590. Okay. Now I'm going to talk to you about the main loop, which is the 3rd block of code, and that's the go sub 800 routine. This next block of code does what I call orchestration. It carries out orchestration. The entry point is, picture it, the scene is set, the voice volumes are probably primed, and it's ready to hand off to some other part of the program. Now, I expected when I started disassembling this thing and finding out what makes it tick, I expected to find interrupt-driven music and static kind of graphics. Static, a basic program-driven graphics, perhaps, or machine language graphics that just carried on independently, or rather to say that the music would carry on independently and the text or the animation would just carry on at its own pace. And that turned out not to be the case. Instead, what I found was this routine from 800 all the way down to the end of the program where the return exists, does some very strange things, and every single phrase of music is executed, and then basic is returned to, and then the next phrase sends the gate off to the SID chip, and then it returns back to basic. And this goes back and forth for every single phrase across every single song in this thing. So hundreds of times in a single song, and I'm going to demonstrate by saying it's probably going to play, it might crash on me, the machine, the virtual machine, but it's probably going to play Jingle Bells. But I'm going to do this. I'm going to say sys S1. See if this works. No, it's not set up. Okay, that's okay. I'm gonna run it from the top and then I'll break it. I succeeded in crashing it. Here comes the snow. Okay, interesting. I'll just let this go. I have to show you something I forgot to about this scene. Okay. Remember when I turned went through various sprites and Jingle Bells? I think that they're still defined now. I hope they're still defined. I'm going to turn the sprites back on for the prior scene, the original Christmas, the original scene. Let me get this out of the way, actually, just so you can see it more clearly. I'm going to poke 53269, comma 1. Okay, that's the C in Commodore. 2 is the lower right side of it. 4 is going to be the bread part, probably. Yep. 8's going to be, I don't know what it's going to be. Let's see. Oh, it's the snow on top of part of it. 16, snow on the other part of it. All right, here comes the best part. 32. See that? I thought that, and 64, and 32 is 96. I thought that these two were actually characters that they used to kind of stack up, until it occurred to me there's no curved character like that in the ASCII set. Not that they couldn't have redefined their own, but it just was interesting. Now the funniest part about this is as it runs, you have to pretend that's not there. These sprites on the right and left lower part of the screen actually move. They move the Y register upwards, so that as this character base snow accumulates, the edges accumulate as well. Let's see if it happens. There you go. See that move right there? See that move? It's fascinating. So anyway, this was something that, one of the kind of tricks that they pulled. Animation. Again, this is 1982. Pretty impressive. So I'm going to break this again. Okay. I'm going to get down here and move this off of the screen. With everything defined now, I'm going to poke. First I'm going to print S1. Good, I have an address now. So listen to this. Poke, sys S1. There are two addresses defined. There's S1 and S2. Those are the two main routines that trigger the music. Print, S2. Okay, and this is S1. So if I sys S1, listen to what happens and watch what happens. Let's see if hopefully you can hear the music, but we'll see. Okay, S1. Nothing. Sys S2. Okay, S1. Hear that? S2. It's a long release. Yeah, it's a long release. S1. S2. I'm going to go back and forth. Long release. Okay, get the idea. Now I'm going to do something which is even more unusual. Okay, I'm going to execute the graphics that make something happen on the screen, and you can probably guess what it is based on what I've showed you so far. I need to go back to my notes to see what that is. Let me go over to here. I want to go to my code, which I've laid out below, which is down here. And let's see. Okay. Here we go. I'm looking at 51973. Okay, watch this now. Sys 51973. Okay, see what happened? I'll do it again. Notice the period following the ready and above what's happening with them. It's snowing. Now if I move up here and make some room for these guys, those guys, it's almost like a game, right? I can make a game out of this, to be honest. There's that. Now I'm going to come down here. And here comes more snow. And there goes my my ready with the period off the screen. Those are going to stop and those are going to continue. So you get the idea. Now, these three elements for every song that carry through the entire basic program for each of the 7 Christmas demo songs, actually 6, because the 7th song has no animation, do various things. The first one actually just does snow. You saw that, the Good Christian. The second one, Jingle Bells, flashes the lights on the tree. Third one, I believe, is Silent Night, and it animates the flame. The fourth one, I think, is Santa Claus comes across the screen. Frosty the Snowman's in there somewhere, etc. And what they do is they cycle between the sound 1, which plays the next note, sound 2, which closes the gate on the next note. Sound 1 plays, it's actually a phrase, plays the next phrase, closes the phrase. And this continues on. Let's see if I can get it to play any more music. I may have already messed with it beyond recognition. There it goes, there's more, okay? So that long delay was probably playing a long release. And it took 3 or 4 phrases for each click. If you've been following the series, you know what I'm talking about when I say musical phrases. There's the list of bytes being thrown at the SID chip. All right, I created a syntax error which will not let me continue now that I've done that. Commodore BASIC's a little bit grumpy when it comes to creating syntax error and then trying to continue, I believe. Let's see. No, it likes it. Good, I'm still good. I won't be able to do a continue, but I can do this because I'm just calling machine language and returning from it. So you get the idea. There's a lot in here. Now I'm going to quickly jump over to this capture of the code. Not the Commodore listing. I'll show it here because it's more neatly organized. I have in here kind of a small piece of code. I'll put it in the on the comments just for fun, or link to where I have this stored. But essentially, these are the variables I mentioned at the very beginning. This silences the SID chip. This is the intro that we saw with the big Commodore symbol and the snow falling and the sprites. This is the first scene, and this is the setup for the scene where it draws the scene. This one 51976. This 51976. That one. Okay. This sets J and K are time delays, and I'll get into this in episode 7. And this time delay is the time between it playing the first part when S1, the sys S1 executes, and it plays that tone. 94 somethings units of time go by. Then it plays the second part, which is the S2, and then it has a delay of 20 units of time, and then it plays the animation, and that goes around and around in circles. I'll show you where that occurs. 800 is where it actually starts. This is now this is something that happens for each of the songs. It enters this subroutine. There's a 0 to 500 delay. It pokes these values in here, which essentially sets up the song pointers, probably some graphics as well. And then it goes subs to 80, and this carries on. Now 850, sorry. 850 pokes 0 into a couple registers, and these are probably, I'm not sure. I think these are the registers I believe that they use to hold the most recent tone played, such that when it comes back with S2, it can AND it with FE hex, otherwise known as 254, which means that the gate bit won't be set. So this goes on until the song's over, essentially. And I'll tell you just briefly and clearly. S1, play the sound. A delay of for I equals 1 to J. J is here 94 for this song. Next, delay. Okay. If K equals 0, ignore that for a second. Then S2, that releases the gate. The release stage of the envelope occurs for the particular tone that's playing, or tones that are playing. For Y equals 1 to K. K is the second delay. Then next. So it does this, then it calls this, which is the update routine that we demonstrated, 51973, which is 51973. That's the snow. There's the snow up there, okay? So you have it. That's a quick decode, not so quick. Hopefully you followed it, but it's a quick decode of how this works. It really quite interesting. Implementing it in assembly language is also very interesting, as I had to. Talk about that another time. The second half of the series will probably talk more about assembly language. Let me tell you this one last part. If peak mark equals 0, then 860. What this does is, as assembly language processes the phrases, each of the musical phrases all the way through, ultimately it hits the end of the song. Once that song occurs, end of song marker occurs, it pokes a value into memory, returns to basic, and then this part checks to see if it's the end of the song. And if it is the end of the song, then it returns. If it's not the end of the song, it goes back. Goes back to here and plays the next phrase. If it is the end of the song, then it goes to here to return, pops back up to the top of the program, which I have down here, by the way. All of the other songs. Pops back to the next one. This is Good Christian at the top. Then it goes to Jingle Bells, and that carries through to the end. Okay, let's shift gears now and head over to talk about the Phoenix Christmas demo, just briefly. Now, this isn't really about the demo. This is more about how do you get or leverage or benefit from just piles and piles of content on the internet that you may want to bring into your Phoenix for your own program. These graphics are rudimentary, of course, developed in 1982 using nothing but characters. Bitmaps were very expensive on a 1 megahertz machine. On the Phoenix F256, quite a bit less so. But still challenging. It's still a fair amount of data, large file sizes, and there's that aspect of not having tools to do this, or at least not having them until now. So let me switch over and I'll show you how I did it. I'll start with a new browser window. I have this, I'm going to paste my search in here. Christmas image 320 by 240. Um, got a list of things here. I'm going to talk about it in a second. Let me just get there first. Images and one of these, I think. Let's see. I pass it? Here it is. So this is the image I used, if you remember, for the demo. This is 320 by 240 by quite a bit of color, actually. So with this on your disk, and I forget how large the file was, and there's a lot of free, there's a lot of sources out there for free bitmaps. I took Ernesto's procedure as published in issue 13 of the same newsletter, Phoenix Rising. Let me quickly show you that. It's page 15, I believe. Yep, page 15 is where it begins. Ernesto contributed this article to the newsletter. It's about illustrating 8-bit dreams, right? And it includes kind of history of graphics on various home systems, arcade systems, famous ones, of course. The Activision Pitfall was amazing, Gauntlet, etc. And then Commando. And then it moves on to what are you going to do about this problem, art on the F256. And he says, before you start manipulating the registers and all that business, there's a logistics problem. And he kind of walks through it. And he talks about, he's going to show you how to create an 8-bit indexed Windows bitmap using a tool like GIMP, which is a free software, and then decoding it and using his utility to convert it into something that we can use readily in Super Basic. In fact, his utility is written in Super Basic. So pages 17, 18, he talks about it step by step. And this is the exact procedure I went through. Now, the context of this article also touches upon tiles, right? He talks about taking this image and slicing it into a grid that he can load into 16 by 16 tiles. I didn't do that. I just wanted to convert the entire image. So this goes even further. But armed with this kind of information, get a copy of GIMP or use something else, create an indexed palette based on the colors that are there. You may need to do some substitution, a little bit beyond the scope of what I'm going to talk about here. And finally get down to, some code. And this is Ernesto's program. So I could show you what it does, just briefly. It asks you for the bitmap file that you put into your machine with an SD card. It loads it, it does some conversion, and it spits out two files. It spits out an FBMP file, which is the raw kind of image with indexed bytes for each pixel for a particular color, and he creates a PAL file, PAL, which is the palette, which contains the RGB 24-bit values plus a gamma value, I think it's called. Gamma value, alpha channel. There's an extra byte that's not used, but there's 4 bytes per color, and there's 256 colors in the map. So it's essentially a 1K file. Is that right? 1K? 4 times 256. Yeah, 1K. It's a 1K file that gets spit out. And then from there, you can load it into your own program, and I'll show you how I did it. I have it in VS Code here. This is my Christmas demo right here. Really, it's just clearing the screen, loading the bitmap object, which is rather large, right? 60 or 70K into memory at 10,000 hex, which is above. Put a colon to show you. It's above 64K. If this was FFFF, this is into the extended memory of the Phoenix machine through Super Basic. I then load the palette, which is again Ernesto's routine. This load palette routine loads it into 7800, which is I think where Super Basic likes to keep the palette. Actually, that's spare memory, and then Ernesto copies it up to D1000 from there, because you can't load it directly into D1000 because of the way that the disk I/O works. And then I turn bitmap on, and there we go. This call is to my machine language program, which I loaded in here, which is the actual code that runs the Christmas music. But that's about it. It's really that simple. So I did breeze through that. Spent a lot of time talking about the first part of the demo, meaning the Commodore's demo, the Christmas album demo. There's a lot of things in there that are interesting to me, and I have more work to do that I'll probably get back to sometime in another month or two to investigate. But we talked just briefly about how to leverage bitmaps in your own program with these resources. So I'll fill the description with a couple of these links, and you can carry on, do it yourself. Please look back in the next day or two if you're watching this day by day, and we'll have episode 6 posted, where we'll talk about modulation and specifically oscillator sync and modulation. Talk to you then.